It is 11:45 and I am happy to welcome Andreas Wick, our technical strategist, digitalization and IIoT at Balluff. His topic will be Think Big, Start Small. And I'm really interested in what you have for us, Andreas.
Thank you very much. Yeah, welcome also from my side to my talk today, to my first talk actually today. And I'm happy to welcome you to Think Big, Start Small, how small projects may pave your way for the big concept. And why I'm going to do this talk is actually because we had the same situation in our company as well. So I'm giving you a little bit of an insight also at the end on how this is going to look like inside Balluff. But first of all, the general idea behind this. So especially when you're thinking about new topics like IIoT projects, they may be new for a lot of people. So maybe for you and for us, it was the same as well. So if you're starting with thinking about IIoT projects, you hear a lot of stuff around in the internet today in the talks and on many different sources as well. And a lot of ideas are going to arise, and you can maybe imagine your first projects you want to make. And by thinking about the first projects you're going to make, you have lots of ideas, a lot of potential you can do. And if you're thinking more and more and more, you will see that lots of topics you have to think about actually are going to come into your mind. You have to think about project planning, you have to think about budget, you have to think about the hardware you're going to use, how are you going to maintain it, and so on and so on. And if it's new for you and if it's new for your management, if you're thinking big and if you want to start big as well, most likely or often it is going to fail and maybe your project even may get rejected. And as such, I just want to give you an idea what another approach could look like. So for example, think big. This is very important. Keep the big picture in mind. Don't let your creativity be packed in a small box. So think big, but maybe it may be a good idea to start small and scale up afterwards. So gain the knowledge, gain the experience, and then scale up to your big picture. And first of all, it may be good to think about what you actually want. So a good starting point here would be just if you're walking alongside your production maybe, or looking at your processes, you may have an impression of friction points. Like for example, a worker of yours is always every month or once per month or once per week coming to you and says, today I cannot produce this product because this material is missing again. Or, the machine today is not working, I have to maintain it, so can you please recalculate the orders and stuff like this. So for this could be a good starting point. So first of all, maybe you can get a feeling for what you want to know here. So this could be, for example, you want to know when your sensor is going to break down. You want to know when your material is going to be empty. Because of this knowledge, you can then make decisions like, I want to reorder now, automatically maybe, would be a good thing to do. So that's the knowledge you want to gain. I need to refill the storage. Then you can think about what information do you need for this. Of course, you need information, what is the actual storage level, but you also need the information, what is the reaction time of your supplier, what is the maximum capacity, what are the thresholds you want to set. So all these informations you need to think about as well. So that's the next step. And then you need to think about what data do I need to gather to get this information, to get my knowledge, to decide what I want to do. And for example, this concept then may lead to your actual architecture. So if you know what data you need, you can actually think about the hardware you need for gathering this data. So it could be, for example, an RFID reader, it could be a sensor, it could be a connection to your to your SAP system, for example. So all these different data sources then needs to be put into your concept. Next, you need to think about your platform, your middleware, where you are going to process this data, where you are gathering the different sources and where are you recalculating them to actually get your information. Because getting a raw value is not the information how many pieces are right now in a material level, in a material storage. And as such, you need a middleware and a platform. And lastly, of course, you need your software application layer where you can think about, okay, I have all this information now. Now somebody needs to get a knowledge out of this information, and somebody needs to make the decisions. This could be on one hand, for example, with dashboards. So you're providing information and your knowledge gainer and your decision maker is in front of the screen. Or it could be even an automatic cycle, so that an automatic order, for example, is done with when a specific threshold is reached and stuff like this. So that's the application level. And that's the evolution from data, from the sensors and devices, to information in your middleware, and to your actual knowledge you gain in your software applications. And also here, it's the good thing, think big, but maybe start small. But to think big and to scale up, it may be also interesting to have a look on which hardware you're going to use. So know the potential of the hardware you're building into your application or you already have in your application. So as an example, if you're talking about sensors, not very unlikely with a virtual event of Balov, but as it's also a good example. So a sensor can be an enabler for you, for your application, because it provides you with data. And if you're thinking about a standard sensor like a pressure sensor, you have a sensor, an input of a physical data, and you get an output as an analog value. And if you want to have another data, like a switching point from the sensor, you need to add another line. And in your SPS or in your PLC or in another interface, you need to have a digitalization of this analog value, and you need to calculate what does this mean in pressure value and all the stuff like this. Another thing I want to show you is an I/O link sensor. So same sensor, also pressure sensor, but this time with I/O link. So you also, of course, get your measurement value. But because you are talking a digital protocol, you can get way more data from the sensor. So for example, the measurement value is already in the correct scaling. You will get data points, for example, switching points. You can get parameter data, like internal device temperatures, condition monitoring data. You can get diagnosis data from the device. And of course, lots and lots of metadata you can use, for example, for asset management. And it's all from one device. And it may be that you only use the measurement value now for your small project. But keep in mind your big picture. You can scale up if you have the potential already built in. So with the standard sensor, you have one sensor and one input. And with an I/O link sensor, you have one sensor and many, many different data points. And the kind of data points can differ. For example, with the process data, you can use directly to monitor your surrounding, and you can use it also for PLC. And the service data, like the condition monitoring data, you can use later on as well. And so from one device, you can get many different kind of data sources, and you have a very big potential inside of your machine. And in your application, of course. So it doesn't have to be a machine. And it doesn't have to be a machine is also a good starting point for going away from the theory, going into the practical application example. And this one is actually one from our logistics department. And we made practically the way directly from starting a small project, because we want to gain knowledge in this topic, to scaling it up and getting the big picture at the end. So let me give you a look at the initial situation. So we in our packaging and logistics department, we have daily orders, and they differ daily because Today, a customer is ordering a sensor, and then you need to pack it and ship it out the same day. So you don't know exactly how much packaging you're going to use today. You can pre-calculate a little bit based on experience, but it's always on demand. And as such, we have a cyclically delivery of our supplier. He's bringing us material, a certain amount every time. And of course, we can call him and tell him, oh, today we need more, today or tomorrow we need more, or tomorrow we need less because we used less. The problem there was sometimes there were orders of the same kind of sensors, and we need lots and lots of the same packaging, and we ran out of packaging. Not a very good situation. Other way around, the same. We didn't use much of this packaging, and we forgot to call the supplier, and now we had double the amount of packaging, and we need to store it somewhere. So we need to plan buffers in our storages. So also not a very good situation. And then we thought, okay, that's a good starting point. That's a small project we can handle. That's something we can also do in a low scale basis. And so we did. So we thought about what do we need to know, what informations do we need, and at first, what kinds of data do we want. And one kind of data would be, for example, the level of the packaging. And for this, we applied sensors to our packaging storages. And these sensors were IO-Link sensors. They were connected to an IO-Link master. Because on our IO-Link master, we have a web service, an API running there. So we can easily use this data and gather this data to put it in our middleware, in our IT system. And because we want to start small, why not start with a hardware that is very cheap and being broadly used as well? So we started by using a Raspberry Pi as a gateway, Node-RED as an open source software, and also Grafana as an open source dashboard. So we had very low investment costs here as well, but also very, very good community resources. So very easy start here. And then we made up our application. We gathered the data, we calculated in a volume, in pieces per storage, and then we distributed it to SAP and to the cloud. Why to the SAP and to the cloud? So SAP is automatically then doing the reordering from our supplier. So that's one cool thing we can do, because now we are never running out of packaging anymore. So that's the first good step. But now why putting it in the cloud? Well, maybe you've heard about vertical integration. That's something we're doing here, because it may be interesting for our supplier to use this data from our storages directly for his production and delivery planning. So he doesn't need to wait for the order. He can have access to our material level all the time, so that he can pre-plan his production process. So that's integration and connection between different companies. So that's also a good thing to do. And it's not theory, we really did this. So these are some example pictures here. You see the mock-up or the first pictures of the dashboards, where we had then knowledge about the different levels of the material. We could calculate the reaction times and stuff like this. And we had 4 packaging storage material storages that we monitored. And we actually made it. We never ran out of material again, and we were able to reduce our storage amount by 50%. That's very cool. And that's starting small, but that led to the big picture. We scaled it up, and now we have it running in our whole logistics packaging storage. And actually, maybe you have heard about the talk yesterday. You can have a look at it in the session library. There is the talk about the MLM, the machine level monitoring system. So that's a solution we can even now offer to our customers. So it's not a benefit only for us, but also for our customers. And so in conclusion, we have many different benefits. It's always interesting especially if you're starting with new topics like IIoT. Start small. It may prepare you for the big concept. And also, partnering up may be a key factor for successfully doing this. So thank you very much. And yeah, enjoy the rest of the virtual event.
Thank you, Andreas, for these great insights. So, in the chat, we currently have no questions, but let me ask you something. You talked about the project. Yeah? How can I find a suitable use case for such an example application?
Because that's actually maybe easier than you think, because if you're starting small, you can figure out local problems. And just ask maybe your workers or your production planners, for example, what requests do you get where you often say, "Oh, again," and that's like the situation, and that's the answer you normally get if you have a problem that's occurring regularly, and that may be a starting point for one of these small projects. So look out for these again moments, and then you may find your project.
Okay. And how does the scaling then work? Maybe you can tell us something more about that.
Yeah. So the scaling actually, the first good thing you get with a small project is insights into the topic. You get knowledge, you get experience, and also very important, your management is also starting to understand the complexity of these topics, and also starting to get the benefits of these kinds of projects. And when you're doing this, and if you have your big picture already in mind, you can prove the possibility of doing it, and the effort is worth it by showing the success of your small project. You can lay out the big picture, and the management then can say, okay, we saw it's possible to do it in a low scale. We have the big picture. Now let's do measurements for scaling it up.
Okay. And why was a Raspberry Pi used in your example that you showed? I thought they are not robust enough for industrial use.
This may be true that Raspberry Pis have a little bit a bad image when it's coming to industrial applications. But for small projects, proof of concepts, it's perfect because you have a big community, lots of resources in the internet where you can dig into this topic, where you can start with this topic. And also if you, for example, have student projects or apprenticeship projects, that's a very good starting point for them as well.
Okay, thank you. And we have one question from our chat. Do you have any idea or experience on the productivity enhancements?
Of course, I can tell you about our projects we did here. We were able to reduce our storage capacity by 50% because we didn't need to plan any buffer anymore, and we were able to nail the reaction times and the limits for the reordering perfectly. So we are not running out anymore of material, and we were able to reduce our storage capacity. But that's only for this project. Of course, every project is different. So depending on the project you are going to target, it may be different. So we have other projects like level monitoring or buffer storage controls or tool identification, for example. Maybe you have heard the tool ID, Easy Tool ID yesterday. That's also a very interesting project where we had the possibility to reduce costs in other regions like maintenance costs and downtimes. So depending on what projects you are going to select, you have different kinds of enhancements. But good thing is, if you're starting small, you're failing small as well if it's not working out.
Perfect. Thank you again, Andreas.
Welcome.
For having your session here this morning. And thank you all for listening. We will have a slightly longer break, and we will be back at 12:30 with our next session. Thank you.